That work? Okay. All right, good afternoon, everybody. I'm Scott Sherrill. I'm with the manager at Mamco, and I get to bore you today with the milling stuff. If you've seen it before, you'll be just as bored this time. All right, I think we all know the benefits of milling now: curb exposure, transitions, and as far as the description for INDOT is concerned, milling is a part of the pavement rehabilitation process where a portion of the old HMA or PCP pavement is removed or planed by a milling machine in preparation for the HMA overlay. Milling purposes and benefits: removal of distressed pavement, improved smoothness, reshape cross slopes, eliminate shoulder work, which is cut out the main line and inlay it, maintain or create curb exposure, maintain clearances at overhead structures, that's bridges, etc. Also, maintain and create drainage, transition between HMA layers, transitions to approaches or other existing pavements, removal of any existing asphalt joint repair material, create a textured surface to help prevent sliding of new HMA overlays. All this stuff's very obvious, you probably know it. All right, so in the early 2000s, when they started to request more of the asphalt guys to improve the quality of the asphalt pavements, the durability, smoothness, etc. You know, the HMA payments came out, and INDOT really started to pound you guys to do better, longer-lasting pavements, better work. So what happened was they quickly realized that the preparation of the surface was a big part of that, what they were getting ready to put back on, and the milling guys could really help them by preparing a better, smoother surface. But there really were no specs in place, you know, to enforce that and to expect milling guys to do a better job besides get out there and go 150 foot a minute. So around 2004, we formed a committee of the asphalt people, INDOT people, and some of the milling guys. And we got together and tried to think for ways that the milling, you know, specs could be standardized. And we used them to set the specifications and actually make that the milling guys accountable and have some standards for which will allow them to help the asphalt paving guys. So after several meetings, what we came up with, we established and adopted methods and standards for the milled macro surface, which is the texture of the milling surface. We also established standards for longitudinal and transverse grade controls, grade deviations, and they also, instead of just lumping everything under one item, we came up with some new milling bid items that created different, you know, descriptions for different items. All right, so that went on basically 10 years. I mean, I can't believe it's been almost 20 years since we were the first time around. But in 2014, you know, I went back to the drawing boards and also established a few more specifications. What these came up with was a new specification for fine milling and coarse milling, and also they added a couple more items to the specification book, you know, to reflect the new specifications for these new items. All right, coarse milling. This is what you're going to see most all the time. This is a standard milling drum, 5/8 inch spacing. This is what you're going to get with coarse milling. It's specified for minimum single lift overlays of 165 pounds or more, and multiple lift overlays, like if you got, you know, binder, surface. All right, so it's capable of producing a macro texture ratio, we'll get into that later on, in accordance with an ITM of 812 equal to or greater than 1.8, and we'll explain the ratio. And the maximum practical two spacing of 5/8 of an inch, which is the industry standard. And it's specified for asphalt milling depths greater than 1.5 inches and concrete milling depths greater than 3/4 of an inch. Fine milling. Now, fine milling is specified for single lift overlays of less than 165 pounds a square yard, you know, 1.5 inches. And it must produce a minimum microtextural ratio equal to or greater than 5.0, which is substantial. The minimum two spacing for fine milling in Indiana is 3/8 of an inch. And the fine milling is specified for milling of asphalt milling depths of 3/4 of an inch in concrete and 1.5 inches for asphalt. INDOT milling items. Okay, so what description for the items that you're going to see on a daily basis is asphalt or concrete scarification. Basically, this is roughening the surface, a minimum amount of milling to roughen the surface in preparation for the asphalt overlay. And the fine milling is required if you're putting back less than 165 pounds. And this item does specify the straight edge requirements, which is 16-foot longitudinally and 10-foot transversely. On this item, you have a 5-day cover up on the main line and 10 days for shoulders and approaches. It's also the macrotexture ratio, macrotexture measuring applies to this item as well. Okay, asphalt or concrete profile milling. This is kind of an engineered item. I mean, it's going to be a little tricky sometimes. It'll basically, the goal is to prepare the base for surfacing by removing the existing asphalt or concrete material to the specified cross slope as shown on the plans. And it might be not just cross slope, it could be depth, cross slope, multiple depths. Like I say, there's a little bit of engineering involved there. The milled surface and macrotexture shall be in accordance with quality control 812. Fine milling for overlays less than 165 pounds. And then the straight edge requirements apply to this item as well, transversely and longitudinally. And then 5-day cover up on the main line, 10 days outside the main line. Approach milling. This is milling the surface and cutting the wedge at the driveways, commercial, or public road approaches. 1/4 inch minimum depth, which is they expect the surface to be roughed up, to accept the overlay to help the sliding. And then you're going to end up, you start off, from the main line, and you're going to end at the back of the approach. You'll end an 1.5 inch termination at the back of the approach. For this item, automatic grade controls are not required. And then the macro texture testing and straight edge requirements are also not required for this item. And this is the asphalt or concrete milling to a specified average depth. This is the one you're going to see most frequently in all the resurface subcontracts. It's removal by milling to a specified average depth. For example, milling asphalt 1.5 inch, milling concrete 2 inch. The things you see in most all the proposals. Again, the fine milling drums shall be used for overlays less than 165 pounds. And macrotexture testing and grade requirements apply, straight edge requirements apply. 5-day cover up on the main line, 10 days non-main line. Asphalt overlay removal. This is your item that for complete removal of the existing asphalt overlay down to the concrete or to a brick. And when you're doing this, you want to set the grade controls and just try to get a good profile. And so if you leave a little bit of material at a joint or on a low-lying brick area or something like that, it's not required to go back and scratch that off. Probably just going to create more problems by doing that. And for this item, because you got inconsistent material as your starting point, at the bottom of the cut, so you're going to have not the macrotexture requirements and the grade requirements, the straight edge requirements do not apply to this item. You just want to try to get it stripped off your concrete or asphalt or concrete or brick as best as you can. Transition milling. This is when you're trying out on the main line. You want to try the transition to between lifts and also transition to start or end of the job or start or end to an existing overlay or concrete surface. Your automatic grade controls are not required on this, but recommended. And the QCP standards for macrotexture and straight edge requirements do not apply to this item. Okay, so achieving macrotexture, which is the measurement they're going to use to see if you're actually doing a good milling job. What matters is the type of the drum used and the tooth spacing. Again, that's the fine milling drum or the coarse milling drum. How fast the machine is traveling, how fast the drum is spinning, and whether or not drum maintenance, which means that the teeth are in good shape, your holders are in good shape, and then also the condition of the existing roadway. If you got a pig, you can put lipstick on it. So it could have unraveling and just may never ever be able to get to that spot where you get a good finished milling surface. It might just be coming apart behind you. Okay, standard cutter drum. If you look at the way to point, but look at the picture at the top. That is your standard milling drum. It's a triple wrap drum. You notice from each end of the drum, you got 1, 2, 3 wraps to center. That's the way the drum works. It augers the material. The drum actually cuts up. While you're moving forward, it cuts up, augers the material across the drum as it cuts, and throws it up on the conveyor belt. And you'll see the spacing between the teeth is 5/8 of an inch, and that not necessarily as they fall in the wrap, but as they hit across the wraps of the drum, the spacing will end up being 5/8 of an inch, and that's your standard triple wrap cutter drum. Most versatile one for deep cuts, shallow cuts, as long as you don't get too fast. That's a drum. What a drum looks like outside of the machine. It's hollow inside. You fill it with put in caps on each end of it and fill it with coolant, antifreeze or something to help keep it cool while it's at work. All right, this is another picture of the drums. This is a standard space drum, and you're looking at the next picture is the fine drum, which is this one's probably 5/16 inch spacing. Look at, that's twice as many teeth. And then you get to the micro drum, which is spacing of about 1/8 of an inch. Some of this not specified for Indiana, but some states do have actually micro texture milling specified, and most of that's out east. And I think a lot of times it's just due because of traffic control that will get, between job phases, they want to go out and smooth the existing pavement, and they can actually feel like they can drive on a micro texture surface. So it really doesn't happen in Indiana much, but it's definitely out there. All right, this is what your pattern looks like, and again, as the drum sits down and the machine's traveling forward, at 60 foot a minute, you see how the teeth are hitting pretty close together. And the drum's spinning at about 120 foot a minute, so that's obviously it's going to, as you're creeping along, they're hitting pretty close together. Now you notice as you speed up to 80 foot a minute, the drum speed hasn't changed, but the travel speed has. You'll notice that you start seeing a bit of a chevron pattern there, which happens as the tooth comes around, it's moved on down the road another foot or two, and just by the time the next one repeats back, you just start spreading it out. 100 foot a minute, even more pronounced. And then at 120 foot a minute, you can really see the wraps are hitting, and there's almost a gap between the next wrap follows up. So if you've seen, if you looked at a road, if the milling guy's flown by at 100 and 120 foot a minute, that's why you see that chevron pattern. It's because he's going too fast. And from the side, you actually, if you see that pattern from the side, it actually looks like scalloping in the road, because you can really see how the pattern's bled through. This is just, we get now to the macro texture, how to test the smoothness of the surface. All right, daily macro texture testing in accordance with 812 is part of the specification. It's supposed to be done daily. We rarely do it daily unless somebody feels like they need to slow somebody down. So, but what happens is they came up with this years ago, and I think when we were still talking at that time about going metric, that's why most all the specification is written in metric. But you take 200 milliliters of glass beads or fine sand and dump it on the milled surface. Has everybody seen this done? basically, take the milled surface, take your brush, clean it off in a particular spot, usually, about the time you get started in the morning. Pour your beads on there. Take your flat, round disc, I think 6 to 8 inches in diameter. Take the disc, put it on that sand, and then you rub it in a circular motion and try to keep a circular, spread as much as you can, which is very difficult. And you keep rubbing that out until the sand doesn't spread anymore. So what the intent is there is the rougher your surface is, at least your sand's going to spread out. It's going to fill the voids, and then you're going to ride that disc over the high spots, and pretty soon you're not going to be able to rub out anymore. So a smoother pattern, that it's going to spread out further. So you take a tape measure or whatever you got and measure across that sand that you spread out in 4 locations, and then you enter that information into your chart and take an average, and these are again working in millimeters, and then get that average macro ratio, or get your average diameter, and go to the chart and plug it in, and then that's how you get, I think we had the average diameter on that previous sheet of 245. That's why you get your macro ratio of 2.36. And that, then you go back to your specifications. Like I said, I think on a standard cut, you're going to be looking at a 1.8, so you're well within requirements there. And so imagine with a fine texture cut, you're looking at 5.0. I think that's going to be a pretty good spread. Probably, I think it ends up being around 14 inches or something across on the average. And that's how you get your macro texture requirement. And again, that's can be done daily. Certainly should be done daily, at least the start of the job, and you guys kind of get a feel for, keep an eye on the milling machine, see how fast he's going, and make sure, they're staying within that limit. I'm sure you guys have enough experience, you can tell when a guy's going, running down the road too fast. All right, so the next part of the INDOT milling requirement for quality control requirement for milling is straight edge requirements. And that's longitudinally, you'll do a 16-foot straight edge at any time over the milled surface and should not deviate at all. I think up to quarter of an inch on the longitudinally. And then take a 10-foot straight edge and measure, check it transversely, which what you want to avoid if you're using a 7-foot machine, you're going to make 2 passes on the road, maybe more. But you want to watch the guys and make sure that they're not, maybe they're cutting 1.5 inches at the center line. They might be 1.5 inches on the other side of the machine, but it might be sitting in the rut or something. So it could be cutting a little bit deeper there. So what you're going to have this here, and it might actually be a little bit deeper. It comes back this way, it might be this way. So you're going to have an inverted crown, or it could go the other way, and the outside might be a little bit deep. So take that straight edge and make sure that it's got a nice profile all the way across there, because what's going to happen, you go to pave that and you're going to end up having trouble getting your densities because you're going to be a little bit deeper or shallower there at that break between the 2 cuts. So that's something you definitely want to keep an eye on. And that's all part of the specification, so you definitely have a reason that you'd be worried about that and ability to check for that. So what makes the grade longitudinally and transversely? Several things. The sensors have to be calibrated and operating correctly. Your down man has to have some skills and experience. Roadway conditions are important, like I say, ruts or something. We don't see them as much as we used to, but definitely something to consider, and where the sensor is laying in regard to that rut. How fast the machine is going, you got to even have to give time for the machine to react, for the sensor to react. The faster you're going, the less time they're going to have to make it. The machine will have time to make adjustments, and also you can. The machines are all now pretty much equipped with a multiplex system, which is instead of just sensing at one zone in the middle of the drum, you actually can spread it out and sense at 3 different points along the side, along the machine and along the side of the cut. And the machine width and the number of passes required. I mean, the 12-foot machines takes that. Obviously, if you're using a 12-foot machine, it takes care of the transverse problem by itself. But we found that we don't have them anymore. We found that they couldn't keep them busy, and it's not really required in Indiana, although I think Illinois does require a 12-foot drum on some some jobs, but that does fix that problem. All right, here's the standard grade controls. On a small machine, it senses basically above the, one spot above the drum and makes a correction there. On the bigger machine, your sensor is in at the center of the machine there at the drum housing, and your rear tracks are locked, and then the adjustments actually for grade adjustments come from the front of the machine. So you get an average, over the distance of the tracks of the machine. Now, multiplex, what you have is 3 points, and this is most of the time it's not really necessary unless maybe on the interstate it makes sense. 2-lane road, probably not worth the trouble, because we found that sometimes the traffic going past and some other things can kind of affect the signal. But so you got 3 points, front, center, and rear, and the machine, the sensors are computerized, and they take all those readings and kind of split the difference, make an average, and give you a really nice profile, and good way to straighten out the road if you got some concerns about bumps and joints and everything else might be blown up. It's a good way to really correct your profile. And then if you two machines, it shows how they work together with the multiplex. And this leveling with side plates, again, that's just what you're going to be using most of the time. It senses there at the drum and makes corrections in the front tracks. Although the new Level Pro system, it actually reads level to roadway, and so it almost kind of floats. And as it reads, gets a signal from the drum sensor there at the drum housing, it actually makes adjustments. But the whole machine almost always maintains its level to roadway. So it's even real nice profile. It almost takes the place of the multiplex. So the Level Pro is really an upgrade from their standard sensors, and you see it pretty much on everything now for the newer workings. And I can't speak for the road techs and the rest of them, but the workings are all going to Level Pro now. It's a really nice addition. I know it's not necessarily for the asphalt business, but machines are capable to do 3D leveling, like a system, Trimble. I think there's a couple other ones too, but Matt will say it's more for a concrete pavement, profile. But we have done it on airports, and it's certainly something if you got a particularly tough job, and you want to get it straightened out. If it's worth the expense of getting it set up to do 3D milling, it's definitely an option that's out there now. I think you do it the same way you would take the truck that runs over it and takes a profile of the old road, and then they go and make a model, and it goes into your computers and your stations, and you end up and that profile guides the cut of the machine. Machine has the antenna on it and gets the signal, and it interfaces with the Level Pro system and makes the adjustments to the cut as it goes down, along the roadway, according to the program, and gets it, I think, pretty much dead on. I don't think it varies more than a 16th of an inch, I think, for most cases. And like I said, we have used it on a few asphalt jobs at airports, but most of the time I think you see it ahead of preparing a base in asphalt for a thin concrete overlay, or that's what we see most of it. And then all this stuff is just more of a talk about the 3D machine, 3D milling. So keeps on going. Okay. All right. So in summary, know your milling items. You know, you always open up a spec book and see what's required for each item, but you're going to know that anytime you got a mainline item, you're going to want to watch your speed, your macro texture, check your longitudinal and transverse, grades, and then monitor the milling speed. And then if you express your concern, if you can see a guy, I think he's hammered down, and he's making a rough surface, tell him to slow down, or if or ask him to take the time to take another macro texture test. Make sure the milling guys we're here to help you guys and achieve your qualities, and certainly you guys certainly have the ability to make us do that, and ask for a good milling job. Monitor the longitudinal and transverse grade with straight edges. Like again, if that on a 2-lane road or any cut, watch for that inverted crown between cuts or a crown between cuts, and that's very important. Get your straight edge out and check that, or ask the guys should have a straight edge with them and ask them to check it. And then in the case of I think you got a really bad road, if you think guys need to run multiplex, they all have it with them. Tell them to put it on. Ask them to put it on. And like I say, with the new Level Pro system, it's not much of a benefit, but certainly wouldn't hurt, if you think it's required. Any questions? Nobody fell asleep? All right.